information from today. Welcome, everyone. This is the final installment of the Bloede Dam Removal Restoring Maryland's Patapsco River series. I'm Jessie Thomas Blake, and I appreciate everyone joining us on this journey that we've been on. This is our fourth of the series of webinars and our last one. So we'll be talking today about the biological monitoring, significant biological monitoring program that we've had out on the Patapsco River. And we'll be having an in-person site visit on July 11th. We do welcome folks to register for that if you're interested. Next week, we'll be sending out more information to folks who have registered specifically for that session about plans for meeting on-site to do an on-site tour. So hopefully folks will join us for, our off-the-record harebrained stories that we're not sharing through the webinar series in a more formal way. I have a few housekeeping logistics to share with you all before we get rolling. You're all muted with cameras off, but you can communicate with us using the chat and Q&A features. Please use the chat for comments and the Q&A for questions. When the questions go in the chat, sometimes they can get lost. So we appreciate if you put all of your questions in the Q&A. That'll help us make sure they get answered. Please take a moment now to enter your name, organization, and location into the chat so we can see who's here. And I think we are going to get rolling. So today we're going to be hearing from William Harbold. William is with the Maryland Department of Natural Resources, and he is part of their Maryland Biological Stream Survey. And he can tell you a little bit more about what that all means. But they've been doing a significant amount of monitoring for quite a long time out on the Patapsco River and have tons of data collected, years of information. And we're going to try to synthesize that all into a brief presentation for you all today. After that, Serena McLean, who you've heard from in our previous webinars, is going to be sharing some of the lessons learned from the project and kind of helping us wrap things up here. And then if we have time, we'll have a little bit of discussion about the project and allow folks to ask kind of broader questions and things like that. So we'll kick things off to start with William.
Hello, everybody. Hopefully you can hear me. Thank you for the introduction, Jessie. Like Jessie said, I work for Maryland Department of Natural Resources with monitoring and non-tidal assessment, and specifically the Maryland Biological Stream Survey. We do assessments of stream health statewide in Maryland, but had worked since 2009 to do biological monitoring on the Patapsco River with these dam removals. I'm going to share my screen now. Hopefully this works. So I'm going to present the results of 16 years of dam removal biological monitoring on the Patapsco River that myself and my colleagues have been involved in. I'm not sure what kind of background everyone here has, so some of this might be a repetition of things you already know. I do apologize for that. Bloede Dam, as most of you probably know, was breached in September of 2018 and was fully removed by May of 2019. And Simpkins Dam, which played an important role in the biology of the river, was removed in 2011. We began monitoring on the Patapsco River in 2009 prior to the removal of Simpkins Dam, and continued monitoring in some degree or another up through 2024 into the post-Bloede time period. There was some overlap in the impacts that we saw from post-Simpkins removal to pre-Bloede Dam and even into post-Bloede Dam removal. But the Simpkins impacts seemed to dissipate quickly following the Bloede Dam removal. And we were able to compare multiple years of pre-removal monitoring to multiple years of post-removal monitoring. We completed the majority of our post-removal monitoring in 2023, but we did continue some river herring monitoring work through spring of 2024. Here is a map showing where the dams on the Patapsco River are located. For any of you who are not familiar with the area, generally sort of to the west, southwest of Baltimore City. The areas that we looked at for our biological monitoring included river herring, American eels, benthic macroinvertebrates, along with related physical habitat, resident fish, and then migratory fish, excluding herring and eels. There was a lot of focus on river herring and eels on their own, but we looked also at other migratory fish that maybe didn't get quite as much attention. And I'm just going to go through each of those groups one at a time. The river herring work we did primarily with spring electrofishing. We had sites both upstream and downstream of Bloede Dam. Post the Bloede Dam removal, 2019 through 2024, we had 3 sites upstream of the dam and 2 sites downstream. We did not sample any upstream sites prior to removal because we had determined that the fish ladder was not functioning on Bloede Dam, and it didn't really make a lot of sense to be monitoring for fish that we really knew weren't going to be there. We did manage to collect river herring upstream of Bloede Dam beginning in 2021. In 2021, we caught, I think, a single alewife and a single blueback herring. In 2022, we caught a handful of alewife and no blueback herring. In 2023, we collected alewife and blueback, again, also in small numbers, and we did not collect either species in 2024. We don't quite know why, but it probably just, they were probably there in small numbers. We just did not manage to find them. Precipitation was a confounding variable for our biological monitoring work. In 2018, we had persistent high water throughout the summer. The Baltimore area got almost 72 inches of rain that year, which was the highest total since records began. There's a picture of the hydrograph from the gauge near Elkridge on the Patapsco River. And right around the time where we would have started our summertime biological monitoring, flows increased greatly and didn't really decrease at all that year. And that might have had a confounding influence on the work that we were trying to do. Moving on into American eels, we collected American eels via electrofishing at 4 sites from 2009 through 2023. We had as many as 20 sites throughout that period, but there were 4 that were sampled consistently with the same methods throughout the entire monitoring period. There was 1 downstream of Bloede Dam, 1 downstream of Simpkins, so in between Simpkins Dam and Bloede Dam, 1 downstream of Daniels Dam, and then 1 that was upstream of Daniels Dam. At these sites, we looked at American eel density as well as the size structure and biomass of eels and the relationship with physical habitat for those variables. And we also operated an eel ladder on Daniels Dam between 2014 and 2023, which was originally unrelated to this project, but sort of almost accidentally became an additional form of monitoring. Looking at physical habitat in the Patapsco River and eel density, we saw that eel density and epifaunal substrate, which is a habitat score that we looked at, track each other very closely, especially following the removal of Simpkins Dam, which occurred in 2011. So we had higher eel densities and higher habitat scores prior to the removal of Simpkins Dam. When Simpkins Dam was removed, impounded sediment was released, was washed downstream, and those habitat scores downstream of Bloede Dam, where some of that sediment came to rest, decreased post-removal along with decreases in eel density. Once Bloede Dam was removed, sediment that was trapped behind Bloede Dam moved out of the area, and then also we noted that sediment from Simpkins Dam that seemed to linger downstream of Bloede also left. And during that post-removal time, the habitat scores increased sort of back to pre-removal levels, pre-Simpkins removal levels. However, the eel density looks like it's tracking up, but did not increase as quickly. And that might be due to slower regeneration times for eels or other factors that we don't fully understand. We also looked at the size structure of American eels at these 4 sites. So the proportion, especially small eels, so the proportion of eels that are less than 5 grams in body weight. And we saw that after the removal of Bloede Dam, which is represented by this vertical dashed line, at the 2 sites upstream of the dam, the proportion of small eels increased greatly, which is interesting looking at the eel ladder on Daniels Dam, which is upstream of Bloede Dam. We built this ladder in 2014 and counted the eels that were passing through the ladder every year since. We had pretty low numbers of eels using the ladder through 2018. And then in 2019, after the dam was removed, we went from around 30 eels per year to 53. The following year, we had 360. Unfortunately, confounding this study, we also had the fish ladder that was on Daniels Dam closed at that same time in 2020. And after the fish ladder was closed, we started seeing a whole lot more eels coming through the ladder. It's unknown how many of those were actually new eels that are reaching Daniels Dam that had not been able to reach the dam before due to another barrier, Bloede Dam downstream, or how many of those eel ladder increases might have just been a rerouting of existing eel passage, but it seems fair to say that both factors were in play there. But the fact that we were seeing a change in the size structure of eels at the site upstream of Daniels Dam does suggest that there were probably more smaller eels moving upstream. So some eel conclusions. Habitat changes likely were a major influence on eel densities. And then the removal of the dam and the ability for more small eels to move upstream likely influenced eel size distribution upstream. The eel ladder certainly helped to monitor eel passage, and the number of small eels that we observed using the ladder was likely influenced both by the dam removal downstream at Bloede and the closure of the fish ladder on Daniels Dam. Should I answer questions as they pop up, Jesse, or should I do that all at the end? I mean, I can see them.
No, I'll bring them back out to you. You can keep going.
Okay, so if you're putting questions in the chat, I'm not intentionally ignoring you. Well, I am, but I've been told to ignore you. So moving on to benthic macroinvertebrates. To monitor benthic macroinvertebrates, we compared data that was collected in the pre-removal period, which was 2013 through 2017, excluding the year 2016, as well as the post-removal period, 2019 through 2023. We had 4 impact sites. We had 2 downstream of Bloede Dam and 2 upstream, as well as 2 control sites, which are situated up and downstream of Daniels Dam, which is all visible on the map here. And at these sites, we collected quantitative benthic macroinvertebrate samples and also assessed physical habitat and substrate types at these monitoring sites. In general, prior to the removal of the dam, the physical habitat conditions upstream of the dam were impounded with fine sediments, and then that shifted to a coarser bottom substrate, going more from sand and mud type substrates upstream to cobble and gravel downstream in the former impoundment. And the percentages of sensitive benthic macroinvertebrates increased both above and below the dam after the dam was removed and those impounded sediments moved out of the area. Looking at some of the results, we see increases in the percents of EPT at our site. So EPT taxa are mayflies, stoneflies, and caddisflies, which are the more sensitive benthic macroinvertebrates. Looking at the top of this slide here, the EPT taxa, the white figures on these box plots are pre-data from the downstream sites, and the blue figures are post, so downstream and upstream. Pre, we had lower percents of EPT, post have higher percents of EPT, and they wind up becoming statistically similar to what was seen at the control sites, which did not change as much. looking at chironomids, which are midges, which are less sensitive benthic macroinvertebrates. Percentages of chironomids decreased following dam removal. And then looking also at a non-metric multidimensional scaling analysis that one of my colleagues did, looking at the sites downstream and upstream of the dam, those impact sites moved to be more similar to the control sites post-removal. So if we look here, this orange polygon is one of the downstream sites. It sort of exists outside of the control, which is all of these blue squares here. Following removal, those sites became much more similar to the control. So the pre-removal is the orange, post-removal is these green triangles. So it moved to become sort of indistinguishable in a way from the control sites. And that is driven by a change from burrowing and collecting taxa to the EPT taxa and clingers and scrapers and things that are more sensitive and more adapted to coarse substrates and flowing water, like what we would see once the dam had been removed. So some of our conclusions for benthic macroinvertebrates, the major habitat shift within the former impoundment increased the riffle and run habitats and decreased the sand post-removal. And that caused major community shifts within the former impoundment, where prior to dam removal, chironomids, like the less sensitive midges, dominated, whereas afterwards the EPT, so those mayflies, stoneflies, and caddisflies became more prevalent. Shifts at the furthest downstream site might have been a result of leftover Simpkins Dam sediment that was evacuating post-removal. And then both control sites showed minimal changes throughout the monitoring period. Moving now to resident fish communities, we performed electrofishing surveys during the summertime at 6 monitoring locations, which were the same monitoring locations that we used for the benthic macroinvertebrates. We looked at data from 5 years pre-removal and 5 years post-removal, pre-removal being 2013 through 2017 and post-removal being 2019 through 2023. And we looked at how the fish communities responded after the removal of Bloede Dam using non-metric multi-dimensional scaling analyses similar to what was done with the benthic macroinvertebrates, also looking at species richness and total biomass, as well as the traits of the fish that were present, whether they were benthic species, lithophilic spawning species, which are species of fish that require clean, coarse gravel substrates for spawning, and then whether they were tolerant or intolerant to pollution. We collected fish using double pass electrofishing following MBSS protocols, which again were done in the summertime. We used a 75-meter block netted reach for sampling. So each site was 75 meters long, and we would set a block net at the bottom of each site and the top of each site, and then do 2 electrofishing passes moving upstream through each site in an attempt to collect as many of the fish in those sites as were possible. And you can see that happening in this photo here. We sampled all of the available habitat within the site and sampled at a density of about 1 electrofishing anode. So these folks with the yellow poles there per 3 meters of stream width. Pre-removal surveys in the Bloede impoundment were complicated by the fact that it was an impoundment and quite deep in some areas. So we had to have some modified methods for several years to account for the depth there. We used an electrofishing boat, which is visible here, and then in some cases used also some electrofishing backpacks along the edges where it was shallower, but we were not able to use those block nets when the dam was in place because it was too deep to do so. So looking at some of the results for resident fish, and specifically at the former impoundment site, which would be site 515, which is this polygon here, and the pre-removal and then post-removal, it became more similar to the control sites following the removal of the dam due to greater fish abundances in the site. There were more benthic species, and then there was an increased velocity and depth diversity. So the fish and the habitat became more similar to what was present in the control sites in the former impoundment, which you would tend to expect. Looking at the former impoundment post removal, there were increasing species richness annually. Diversity indices for fish were consistently higher, and there were a higher percentage of benthic adapted species each year in the former impoundment. The percent of benthic adapted species also increased at sites downstream of the former dam post removal, which could be, again, some of that lingering sediment from Simpkins Dam that seemed to move out of the area once Bloede Dam had been removed. Some conclusions on the resident fish. Multiple metrics that we looked at showed that there was a notable change in the fish assemblage in the former impoundment, really within the first year after removal. And the changes in physical habitat are likely responsible for that. We went from a lentic impounded system to a lodic flowing system, and fine sediments to coarse sediments. So different habitats for fish and better habitats for a lot of the riverine fish that we see there. Also, the historically high flows in 2018 might have contributed to some of the observed declines that we saw at some other sites in the early portion of the post-removal period. Now, the migratory fish, so those beyond just the river herring and the American eels, we looked at fish data not just in the dam removal period, but throughout the entire period that the Maryland Biological Stream Survey has data available for this. So dating back to 1995, there were a total of 121 sites in the Patapsco River and its tributaries that we were able to look at to see what species of fish were present above the dam and below the dam, and then be able to say what species might be new to the area after the dam had been removed. For this, we excluded any sites that were upstream of the Liberty Reservoir, which is a drinking water reservoir for Baltimore City that is in the Patapsco River watershed further upstream from Daniels Dam. That dam is, I believe, like 50 feet tall and does not have a fish ladder on it. And it was built sometime in the 1950s and is still there. Baltimore's not going to get rid of its drinking water anytime soon. So we figured that any site upstream of that reservoir would be completely isolated from changes in fish passage resulting from the Bloede Dam removal. And then, like I said, we looked for changes in fish distributions following the removal, looking at all of these sites. So here's a map of the sites that were available for us to look at. So Bloede Dam is located here. Most of the work that we've done specific to the dam removal projects in partnership with American Rivers have kind of been in this part of the Patapsco River, like from Daniels Dam down to the Elkridge area. But to look and see what is present in the watershed, we went throughout the entire watershed looking at all of the available sites in the Maryland Biological Stream Survey database. There were a variety of sampling methods used at these sites, both single anode backpack electrofishing, boat electrofishing, double pass quantitative surveys. There were single pass, more qualitative surveys. We also used fish traps and hoop nets at some sites for this project. So looking at all of this data, since 1995, there have been a total of 61 species of fish observed everywhere in the Patapsco River watershed. Of those 61 species, there were 9 species that were seen for the first time upstream of Bloede Dam following the removal of that dam. So those included the alewife and blueback herring that we had already looked at specifically. Also gizzard shad, striped bass, quillback, white perch, yellow perch, chain pickerel, and northern snakehead. All of those are pictured here on the right of this slide, and all of these are actual fish from the Patapsco River that we collected at sites upstream of the dam while sampling. So like I said, the removal of the dam allowed 9 species to move further upstream. Most of these new species were observed during their spawning seasons. And we expect that species ranges will likely continue to evolve over time. We hadn't seen very many river herring upstream, but we suspect with more time, maybe we'll see more river herring moving upstream. Most of the expansions of fish that we've seen following dam removal are positive. Northern snakehead, not as much. That is an invasive species that is present in the Patapsco River and an increasing number of rivers everywhere in Maryland. So it was expected that we would see those upstream. We had collected them downstream pre-removal. So sort of something that we thought would happen, and it was unfortunate, but a known issue with them moving. So in summary, the Bloede Dam removal impacts primarily related to habitat change and barrier removal, restoring the lotic flowing habitats and core substrates in the former impoundment had a notable impact on the resident fish and benthic macroinvertebrates that lived there. And then transport of sediment downstream did seem to have negative impacts on eel density, but those do seem to be abating. And then removing a barrier had allowed the dispersal of 9 species of fish and a greater proportion of small eels to move upstream in the watershed without the dam there. And then any questions?
Thanks, William. Folks, you can put your questions in the Q&A function, and we'll ask William to answer those. William, the first question that we have is, why was the fish ladder closed at Daniels Dam in 2020?
The fish ladder on Daniels Dam was closed in 2020 in an effort to reduce or at least slow down the spread of northern snakehead in the watershed. Fishing and boating services in Maryland DNR realized that without Bloede Dam downstream and a functioning fish ladder on Daniels Dam, it was kind of a free passage for those fish to move further upstream, which they wanted to avoid if possible. So in 2020, we closed the fish ladder, which was a little complicated because we're also trying to allow the passage of river herring upstream. So it got a little contentious within the department. Like some people wanted it closed for invasive species reasons. Other people wanted it open for migratory fish reasons. But the concession was keep the ladder closed until river herring are collected at the dam, like at Daniels Dam. And throughout the study, we never did collect river herring at the dam, but we're collecting snakeheads, sometimes in relatively large numbers. So the fish ladder stayed closed and has remained closed as a result.
There's a follow-up question related to snakeheads, so I'll skip to that and go back. Are snakeheads in the river year-round? Are they more abundant at any particular time?
Snakeheads do appear to be in the river at least in the spring through the early fall. Like we've collected them at sites during spring migratory fish sampling and also sometimes during summer resident fish sampling. I can't say when it gets really cold outside if they're still there because we're not monitoring at that time. The adults do seem to be more common in the areas that we were monitoring during the springtime. They do seem to move upstream further into the river, probably from the tidal portions to spawn in the spring, and seems to concentrate at Daniels Dam. They see similar thing at the Conowingo Dam on the Susquehanna River. Snakeheads seem to collect there in the springtime as well. But that's about all I know about that. And then I don't know of any patterns for chain pickerel. Chain pickerel were one of the species that was found upstream of the dam for the first time post-removal, but it was one individual. And I think even downstream of the dam, we might have 1 or 2 records. I think chain pickerel are more common in the tidal portion of the river, where my group did not really do much monitoring work. So I can't really say too much about them.
Great, thanks. The next question that we have is, has eDNA been utilized in determining species presence before and after dam removal?
So Maryland DNR has not done any eDNA work in the Patapsco River, but some of our colleagues at the Smithsonian Environmental Research Center have done an environmental DNA project specific to river herring. I know they were collecting eDNA or water samples for eDNA analysis above and below Bloede Dam, as well as above and below Daniels Dam. But it was not anything that my group was directly involved in. I think CERC, the Smithsonian Environmental Research Center, did get some eDNA positive hits upstream of Daniels Dam following the removal of Bloede Dam. And it's quite likely that there probably were some river herring that made it above the dam. Our electrofishing monitoring for river herring in the springtime was at 5 sites, like I said earlier, 3 above the dam, 2 below. Each of those sites was between 100 and 200 meters long, and we were there for actually electrofishing for 35, 40 minutes once a week. So there's plenty of time for a school of herring to come through and not get seen. So I would not have been surprised if there were a few that squeaked above Daniels Dam that we didn't see, that were picked up by the eDNA sampling. And then they were, the CERC folks were pretty disappointed when the eel ladder, or rather when the fish ladder got closed on Daniels Dam, because that pretty well shut the gate for, literally and figuratively, for any river herring that would get above Daniels.
Thanks. And I put the link for our Patapsco River Restoration Project research webpage in the chat. You can see some of the results from that Smithsonian Environmental Research Center study have been published already. And so you can see links to that among many other publications related to various aspects of this project. One thing that William hasn't mentioned is that MBSS is working on 4 different publications on the various different types of species that he discussed today and the results of their monitoring efforts out there. So hopefully we'll have ultimately sort of a whole suite of publications that folks can reference on the results of these various studies. William, we have a few more questions for you. One of them is, what plans are there, if any, for future fish and macroinvertebrate monitoring in the vicinity of the former Bloede Dam site? And has funding for such monitoring been impacted by cuts at the federal level?
So
I can answer the second part if you can answer the first part.
I am not aware of any plans that the Department of Natural Resources has for either fish or benthic macroinvertebrate monitoring in the vicinity of Bloede Dam. All of the monitoring that we did was funded by American Rivers as a contingent of like the permitting for the dam removal. There was requirements for monitoring. And once that monitoring obligation had been met and the funding had been expended, we stopped our involvement in the project and have moved on to other things. Certainly, if funding comes back around for more monitoring and our group is asked to do it, we would, but I don't know of any at this time.
Thanks. So American Rivers is working on a feasibility study on the removal of Daniels Dam, which is now currently the farthest downstream dam on the Patapsco. If Maryland DNR decides to move forward with removing that dam, then there would be like a much more like sort of shrunk down version of monitoring that would just be covering some basic aspects that would be required for permitting out on the Patapsco. So it wouldn't be the full breadth of what William is describing. And that would be some couple of years down the road. So we don't have plans currently to continue this particular effort. It's closed out now. And I do believe that federal funding cuts are impacting funding available for this type of monitoring. Next question, William. We have a few, so we'll see if we can get through the rest of these. This was a fairly comprehensive story of fish abundance and community dynamics through time. Nicely done. Did you happen to make any attempt to pit tag for estimates of abundance using mark recapture or acoustic tags for finer positional movements in any species?
So we did not do pit tags or acoustic tags in any species as part of this project. we had talked about how it would be nice to do certain things, especially with the eel ladder. There was always a question of like how many eels are going through the fish ladder on Daniels Dam versus the eel ladder on Daniels Dam, and we thought that a way to figure that out might be to put tags in eels and see which way they go. Would be relatively simple to put a receiver in the fish ladder and a receiver in the eel ladder. The problem, number one, we didn't have funding for it, and number two, the eels using the ladder are very small. They're like 90 to 110 millimeters, and it was hard to put a pit tag in a fish that small. The Smithsonian Environmental Research Center was doing tagging of river herring. They put pit tags and I think also acoustic tags primarily in blueback and alewife herring. I think they also put tags in some other species that were moving through the river, quillback, maybe even like some carp and other things, just to like test and make sure that their antennas were working. And I think a lot of that data is probably available in the studies that I think Jesse was talking about linking a couple minutes ago. Like we helped with collecting some of the herring that they put the tags in, but no, DNR itself did not do any tagging.
All right, we've got one last question before we move on, and that is, what is the status of the eel ladders? Are they still passing eels?
As far as I know, the eel ladder on Daniels Dam is still passing eels. It was redesigned and kind of rebuilt. It was either last year or the year before, when the funding that my group was receiving to build and operate and monitor the eel ladder on Daniels Dam ended, which had been part of a mitigation package for dredging in Baltimore Harbor. And it was unrelated to American Rivers or to dam removals. It just was convenient that it sort of overlapped with the dam removals. When that funding stopped, the operation of the eel ladder was taken over by the Fish Passage group within Maryland DNR. And they have kept the ladder going. They replaced it, I think, with some larger diameter PVC pipe because the original steel channel that it was made out of was starting to degrade and fall apart. It is still there. I have not heard that it isn't passing eels, but I've not been directly involved, so I don't have any numbers on it. And I know that it was rebuilt sort of on a very budget-friendly way with the PVC pipe because of the Fish Passage folks, at least, are hoping that it's temporary until that dam is potentially removed. But like Jesse alluded to, DNR has not made a decision on that, and I don't know what or when that decision may be. So.
Great, thank you, William. All right, at this point, we're going to turn things over to Serena McLean, and she's going to share a little bit about lessons learned and kind of help bring all of these various talks that we've been hearing over the past few weeks together.
Jesse, and thanks, William, for sharing all that really good data. It's been really exciting to follow along. I'm going to kick this up really high level. You know, when Jesse and I were talking about this series with Katie, you know, I kept asking myself, like, what do I want people to know? Like, what, you know, all of this is really interesting. And, you know, if you want to geek out with this, that's awesome. But what can you take away and potentially use for the projects that you're doing? I will tell you right now that my motto has been and will continue to be always be fundraising. And just to give you, okay, well, we didn't mean to skip ahead. Just to give you some data so you can put this project in context. So these are ballparks, keep in mind, but for engineering, design, and oversight, we spent roughly $1.77 million. Construction on this project, which does include, again, relocation of 2 sanitary sewer lines, removal of the dam, rebuilding a historic wall, and protection of all the infrastructure, was $18.6 million. And on the monitoring that you've heard from William today, as well as, you know, the monitoring that Matt and Stephen, the sediment geophysical monitoring they presented on earlier in this series, our monitoring costs were roughly $1.9 million. So, more complex projects like this are expensive and they span multiple years. And so once the owner was on board and willing to consider removal, we began fundraising. And honestly, we didn't really stop until roughly a year after construction in 2019 when we secured our last bit of monitoring funding. So, keep that in mind when you're embarking on projects. I consider, again, fundraising is an ongoing process, and also just be ready to take advantage of transformational funding opportunities. I know transformational is like a big buzzword, and the BIL IRA funds weren't around when we did this project, but there were still larger opportunities that we weren't expecting that came along that we took advantage of. For example, this project did receive funding through the American Recovery and Reinvestment Act. And we had a couple of different pots of funding that came out of the Hurricane Sandy disaster recovery funds. Some of the state funding, while they came from certainly engineering and construction, there were different state pots of funding we were able to leverage for boating and recreational access because of the location of this dam and the fact that we'd be able to create safer boating passage and recreational passage through removal of the dam. So number one, always be fundraising. Be project's publicist. This goes hand in hand with the previous lesson. When we were doing the projects on the Patapsco, Bloede in particular, I talked to anyone who would listen about this project. Jesse and I have led so many tours of the Patapsco River, starting from the earliest of days. I wanted to generate interest not only among the community, but really among federal and state agency staff. I wanted to generate interest within my own organization and with funders. Basically what I wanted to do is I wanted everybody to know about this project, the fact that it was a big deal, and I wanted them to get excited about it because I knew that at some point I would come to them with an ask, be it for money, be it for technical assistance, be it for something, and I wanted them to be excited enough to jump on board. And so I think, it can be uncomfortable at times to have to talk about your work so frequently, but I do think there's a value to it. And don't get me wrong, this won't work for every project. You can have a fantastic project that restores important habitat, but it really won't require this level of attention. American Rivers has plenty of small projects in rural areas in the middle of nowhere that are really great for fish, but we're not going to publicize in the same way. But you are the advocate for your project, and developing the skills to do so and developing a willingness to do so will help you down the road when you need to line up funding support, when you need to keep people excited about an 8-year-old project that is still going and hasn't gone to construction yet. So be your project's publicist. We talked about this in the regulatory meeting, but this, I really want people to kind of really keep this with you, but don't be afraid to negotiate during regulatory review. Again, there are certain codes in process. There's always like the way things are done and the way things are permitted, but I still contend that, all things can change, even the regulatory requirement if you provide the right information. And, you do have to have the data and the technical documentation to back up some of the things you're asking for. But again, don't be afraid to negotiate during regulatory review. We talked about this a little bit last week, but I do think that no matter your project, the backbone of any good dam removal project is your project team and the design, construction, and other documents that guide them. It's basically, this is the boring process stuff, right? Like having a really good, solid team and knowing how you're going to make decisions and then having that documented to be able to follow is incredibly important. One of the things that I look for when we're hiring at American Rivers or we're building a team is I look for smart, creative people with grit and self-motivation, right? Like I don't need a lot of people who just want to listen and like hang around. That's cool. We can do that. But I need doers, and I need doers who want to get things done. We look for skills and strengths that fill much needed gaps. We talked a little bit about this in terms of bringing on folks like Matt Collins, who was there, who had an expertise in fluvial geomorphology and sedimentation to help lead and guide and help us craft that component of our monitoring plan. It's folks like Mary Anders, who was with NOAA, who was, you know, an engineer and who really did provide much needed backup and review of some of these engineering and design documents for folks like me, who aren't an engineering and designer, and to help catch those things. So again, like, your team that you surround yourself with is incredibly important and only going to make your project stronger. Match your level of effort to the scale of the project. Again, not every project requires the level of the monitoring and investigation that we put into restoring the Patapsco. You know, yes, the project was complex for a couple of different reasons. One, for social reasons. Two, just, you know, from the regulatory standpoint. But, you know, one of the reasons why we invested so much time and funding in this project is that we wanted to begin to open up the regulatory process in Maryland, to consider more process-based restoration techniques. We wanted for the regulatory agencies to begin to see and have data on, you know, whether or not they should be regulating working in the wet, right? Whether, you know, sediment could be allowed to move downstream. So using this project as a model, and you know, a test case to both educate the broader community, you know, as well as the regulatory agencies ourselves, like, it was worth that investment of time in $2 million worth of monitoring in an adaptive management plan. And again, that level of effort. Not every project's going to need that. Like, pick and choose which projects you can use in your state or your region to get like a bigger bang for the buck. Leave you with the fact that this was my one big takeaway, and I kept coming up with all these like hollow sentiments, like, keep calm and carry on. Like, you can do anything. But at the end of the day, like, you will encounter challenges, right, when working on a dam removal project. And I think it's really important to keep your wits about you and know that, like, again, if you've got the team behind you, if you've got your processes, like, you will get through it. You know, and I thought about when talking about lessons learned, you know, whether or not I wanted to share, you know, a lot of specifics, more specifics about some of the challenges we went through and how we navigated them. And I came up with this one particular example. Jesse touched on it lightly during our construction conversation last week, but two of the things we had two challenges when it came to rock, both the amount of rock and the strength of rock that our construction crews uncovered during the process. We discovered that the volume of rock under the gristmill trail where we were to place the new sewer line was, you know, a bit more than what we'd estimated, right? To the tune of roughly $800,000 in additional costs. So that was one place where, you know, our geotechnical borings could have shown us something different. The other thing was, and this is what Jesse alluded to, is when we were drilling for the micropile wall up near the pedestrian bridge. The construction crews discovered that the strength and the density of those rocks was substantially, once they drilled down past the first layer, was substantially more significant than what our geotechnical borings had shown, to the point of where, and this is what Jesse shared, it was breaking, had the potential to break a bit on the machinery. And to put this in context, this particular bit was $30,000. Again, everything is money, time and money. How do you solve these things? And so in reflecting back on the project, and, you know, we've talked about this, like, was there something we could have done differently in our geotechnical borings that would have allowed us to kind of have this knowledge ahead of time? And what I'm showing you on the screen is a map of a plotting of all of our borings, our geotech probes, and others. And at the end of the day, we poked the impoundment area, and I don't have the map of, you know, the upper limits in the impoundment, but we like dug down into the impoundment quite a bit. And what you're not seeing on here is we actually went back after we developed this map and collected 10 additional borings along the gristmill trail alignment, specifically for the sewer line. And I'm sharing that because, you know, again, reflecting back, you know, could we have done more? should we have invested more in geotechnical borings so that we have known the amount of rock? And I'm personally left with the knowledge that I don't think we would have wanted to have. You know, the way in which the rock was in this particular valley, it would have been was incredibly easy to miss, right? It's not this uniform layer of rock that you're going to hit. Like it was just all over the place. And so adding additional borings wouldn't have guaranteed that we would have hit the right pocket. And there was some sonar done in this area as well. It's not reflected on here. But I do think that because we had processes in place to deal with the challenges that came up, right, and navigate what this potential change order meant, we were able to handle it and address it without too much fuss. It also gets back to the always be fundraising. Make sure you've built in some contingency to both your design and construction costs to account for some of these unforeseen challenges. And I think we've said this in all our talks, but again, you know, there was an incredible wealth of knowledge and expertise that invested in this project and that were with us along the way. And you've been able to meet a few of those folks while we've done this webinar series. You know, there's certainly other folks who played an integral part of this project that we could connect you with if you want to learn more. But thanks for hanging with us.
Thanks, Serena. If folks have any sort of parting questions for Serena, feel free to pop those into the Q&A. We'd love to hear from folks about how you feel about this webinar series. Do you feel like this was useful to really dig down deep? You can provide us feedback through sort of the official survey that comes out at the end of the webinar if you're not interested in sharing. You know, we'd love to hear from folks about, you know, does this, you know, help sort of think through bigger projects that you might be considering? How do we kind of make these things happen across the country, these types of projects? If anybody wants to share, I can unmute you. So if you tell me in the chat that you'd like to actually share your thoughts with us out loud, let me know and I can find your name and unmute you. I can't unmute everyone all at the same time. And if no one has any thoughts to share, then we'll go ahead and close it out for today.
Thanks again, everyone. Happy River Month.
Thank you,
Thanks,
Jesse and
everybody.
Serena.
We appreciate you attending, and we hope that you'll join us on July 11th to see the site as it is today, and, you know, hear some of our fun background stories. So thank you all.